You're good.
Alrighty. Well, hello everyone. I'm Quinn and this is my end-of-year presentation for Artemis Archery Technology. So, just a little bit about me. I've been doing archery since 2018. It's my whole life. I am on the regional elite development team, which is basically the regional junior Olympic teams. Archery is everything for me, and I hope to continue it in college. I have also been on a few other local teams, so this is what grew my love and started my ideas for this project. For classes, I live down in the engineering room. When Combs talks about the kids that live there, it's me. I keep food in their fridge. I've taken every class. That's my room. And then clubs, I am co-president of robotics. I'm in leadership for women in STEM. I do technical theater carpentry. I'm in NHS, National Honor Society, and I've participated in Technical Student Association. Here's just a few pictures of my work. Here's our robot up here that took us to state. Here's a few shows I've worked on. Here's me at national archery events shooting. And here's some smaller projects I've done. So I was really excited for this opportunity to start doing larger scale projects. So let's get into it. Oh, one more thing. I'm going to college at South Dakota School of Mines in the fall to study mechanical engineering with a minor in robotics. Very excited. Go Hard Rockers. So, quick project description. I have tried to create the bow that Hawkeye uses in the original Avengers movie. I wanted to be able to mix my love for archery with my love for engineering and make a pretty cool product out of it. If you guys haven't seen the Avengers movie, here's a video of it. And it plays a few times to slow it down so you can actually see it. I did later find out that that was entirely CGI. They didn't even make a model for it. So that was really disappointing and upsetting to know that I'm making something that not even Marvel wanted to figure out. So, my project objectives. So, I really wanted to improve my public speaking skills. I'm hoping you guys can't tell, but I'm very nervous right now. I wanted to better my time management. Going into college, engineering programs are hard. I need to really be able to get on top of things. I also wanted to improve my knowledge on the engineering design process. When I build something, I just go straight into it. I don't plan. I just hope I can figure it out along the way. And then I get really upset if it doesn't work first try. So I wanted to work on the planning, the process, and doing reiterations, keeping my cool. Another one was I wanted to better my skills in perseverance. A long-term archery program and engineering takes a lot of perseverance. Things go wrong, it's normal, so I wanted to make sure I didn't have an entire meltdown every time something went wrong. Then finally, I wanted to better my skills on the manufacturing process. Going into engineering, it's very important you know how things are made, so when you're building something on CAD, you don't make it entirely non-manufacturable for the people that build it, and you don't want the people that build it to hate you. So I really wanted to work on the process of making buildable designs. So my expert advisor is the wonderful Mr. Alex Gillum. He is beyond qualified, and he's been so helpful through this whole process. He's just received his master's in mechanical engineering from Texas A&M. He is one of the build captains on A&M's Formula SAE team. They just basically make little race cars. It's very cool, and I plan on doing that in college. And he's on Team USA for the 2024 season, and has shot for A&M's team for 5 years. He's been so supportive and so helpful, and I'm forever grateful to him. Then my other advisors, the women in STEM, who I like to call the board, Aishvi, Felicia, Chelsea, I went out of order, Bella, Lena, Harriet, and Nevada. They've all been so helpful to me, keeping me on track, keeping me from losing my mind, just having fun. They've also turned into some of my greatest distractions, unfortunately, because I just want to hang out with my friends. Mic is close. And then my parents. My parents have been endlessly supportive through this whole process, whether it's my late night builds, things going wrong, or giving me financial support to make this project happen. I'm so grateful to them and my whole family that came to support me for this project. So, my timeline. A very common theme with the STEM projects is we all had these great plans to get it done so early, and it was going to be easy. And then things happen. So this is my revised timeline. Do a better look at the glance. So in October, I plan to do a little bit of research on the physics of the bow. And in November, I just wanted to research all the components I was doing, and design the entire bow in less than a month. And in December, I wanted to do all the complex little tiny mechanisms. Then I wanted it entirely built and tested by January. And then February was just going to be little tiny tweaks, testing and modifying. So was March. And then all of April, I was going to be chilling, getting my other classes done, all that easy stuff, getting the presentation. So as you guys could probably tell, not close to what happened. There was a lot of things I didn't anticipate. This was a much harder process than I thought it was going to be. Well, it was going to take me like a week to build it. Did not. Took me closer to a month. And then research. I thought I had all the knowledge I needed. I've been doing archery for forever. No, there is so much that goes into it, which I will talk about later in my process. Additionally, I didn't factor in things like journals and presentations. Documentation is incredibly important for the engineering world. You need documentation to be able to be taken seriously and to be able to prove that your work works. And so they took a lot of time. So I did not anticipate that. And so it ended up being more, we did introduction presentations and project planning in October, research entirety of November, and doing a journal. And I also was fortunate enough to be able to meet with my advisor in person when I went down to shoot at Texas A&M. And then December, I designed my riser in CAD, ran into a few issues, which I'll talk about later. And then January, I designed the limbs and the small parts, and then we did our mid-year presentations. February, I did some early welding and just some basic skills. And then I got to meet with my advisor again at the Las Vegas shoot. And then March, I did the middle split on my riser, and then started welding the caps. And then April, I finished the welding, finished the whole design, and worked on my final projects. So what is a bow? I have a wonderful volunteer to help me show you guys that. So this is Bella. Everybody clap for Bella. A bow is made up of three major parts that I'll be talking about. There's the riser, this big part, and then there are top limb and bottom limb. All of these are very important to how the bow works. They basically make the whole spring force in the bow. Now to shoot a bow, this is a foam-tipped arrow. It's entirely safe. I've been using archery tag, so Bella's volunteered for this. I didn't make her do it. When you draw a bow back, you want to draw all the way to your face, and then you let go. And it hits Taylor, who's also a volunteer. So, thank you, Bella. Everyone give Bella a round of applause. So, that's how bows normally work. But with this comes a lot of problems with where the forces are and everything. And then I had to choose the type of bow I wanted to modify. So, there are three major types of bows. This one is my baby. It's the bow I shoot in competition. This has been to all of my major competitions with me, and it's fantastic. This is an Olympic recurve. It's an almost identical setup to the women's Olympic team that got silver last summer. So this is my baby. But it has way too many pieces and parts to be able to modify. It's very specific, and unfortunately bows like that are very expensive. So I don't want to risk messing them up. Then we have our second type of bow, a compound. These are the ones you see a lot for hunting. They have a very strong draw, and they have let-off. These give you the mechanical advantage in archery, meaning they're super intricate, and a lot of things can go wrong. I also don't shoot compound, don't really know anything about it, and I'm afraid of these, so I was not going to get close to modifying that. Then, finally, we have a bare bow. This is the one I just shot Bella with. But they're pretty simple. Riser, limbs, string, easy to use, easy to modify. So I finally settled on modifying a bare bow. Thank you to Bella once again. So here's my quarter one. My quarter one was pretty much entirely research on previous attempts, the dangers of archery, and the physics involved. So some previous attempts. The Marvel movies are very, very popular, so of course people have tried this before. But there are problems with how people have tried this. These ones over here used leaf spring metal as the limbs. That is well over 70, 80 pounds. Trying to draw that would cause me injury, and I don't want to mess with that. Additionally, using metal doesn't make it a traditional bow anymore. But one thing I did like was these limb caps. It's very important to reinforce the stress points of the bow, and so I wanted to take that from it. The second design was this one over here. It was entirely 3D printed, so it's very, very brittle. The person who made this ended up using a piece of elastic as the string, so you're not using the actual spring force from the limbs, it's just the elastic. So I didn't really like the idea behind that either, but I did like that the limbs had hinges on them. So I took one or two ideas from everything, but overall I had to try and figure out how to make the whole thing myself. So, dangers. You'll hear me talk about it a lot through the process, but safety was my #1 priority through this whole thing. Archery is a dangerous sport. People think it's a dangerous sport because you might get shot by an arrow, but that rarely happens. Archery is a dangerous sport because of equipment failures. I have seen both of these equipment failures happen to people I know, where your limb breaks or your limb delaminates. This sends wood and carbon fiber at your face, and it causes the string to snap at you. I've actually had an issue like this happen to me where my string snapped. It left a mark of a Y on my face and on my arm. So I've had my tussle with problems, and I did not want to do that. So safety has always been my priority through this whole process. Additionally, another issue, if you build an inconsistent bow, it will deliver power inconsistently to the arrows, meaning there will become weak points. Weak points in arrows cause them to fracture and go into your hand. Not something I want to be messing with. So safety was a huge priority through this whole process. The physics. Lots of numbers, lots of crazy things. Archery is entirely physics. If you take a physics class here, you'll probably do an archery equation or two, because all these are really big, weird shaped springs. And so I had to do a lot of calculations to try and make sure I wasn't overbowing and maxing out my force. The bow I'm modifying has roughly 100 newtons of force. It's 15 pounds of force in our normal talk. But an additional thing with archery is that the longer you draw a bow, the more force it has. So I wanted to make sure this bow was specifically curated for me, given that I have a shorter draw length than most people. And so I'm not really letting other people touch it, because if you overdraw it, it has a possibility of snapping. So quarter two. Quarter two, I focus mostly on stringing, bow length dynamics, and a lot of CAD. So much CAD. So stringing. Bow strings are where the power is loaded into the limbs. They are very important to be able to make sure you have a safe and reliable string, as well as the right size. So I had a lot of strings for my years of archery. Of course, none of them worked, and so these limbs and riser are not regulation size, so they're much shorter than normal. So I had to go find specific strings. Later I'll talk about with my struggles of strings, but stringing was a very important part because originally part of my design was wanting to make it self-stringing. So I did a lot of research on this. And this bow length dynamics, I touched on this slightly, but the more you draw a bow, the more force it has. I, on my current bow, use medium limbs, but my technical draw length should be short limbs. So I had short limbs for this bow to make sure I was getting perfectly in the power stroke and not over or under drawing. And then CAD struggles. There's a sound that should play in a second that is all of our worst nightmares. It haunts my dreams, and if it will play,
Oh, man.
I've been having problems with this thing for a while. Oh. There it goes. It haunts all of our dreams. It's the SolidWorks error noise.
Oh.
I actually played an hour-long video of this just to make myself work. Oh, the audio's not hooked up. Sorry guys, it's just a little ba-dum. But I had a lot of over-defined sketches through this process because I would go through and make sure everything was perfect, and then I want to add just a little more perfection, and then it'd tell me no. And so that was a huge problem when I was trying to model the very specific parts of a riser. Risers have a lot of curves along with limbs, and the curve is variable, so it doesn't have a consistent length I have to do. So I went through, I measured it out by the millimeter. It was just very, very particular with this whole process. Another issue was that SolidWorks killed my whole computer. I tried to update SolidWorks over winter break, and it refused. It had a toolbox somewhere from a previous year that no one could find. I brought it to Combs. I brought it to George. I tried myself. We looked everywhere. We couldn't find where this toolbox was from. Was never able to fix it. I even contacted SolidWorks, and they didn't know why I had this problem. So I eventually just gave up, wiped my whole computer, and rebooted it. Now I have more storage though, which is pretty cool. Then finally, success. I have my full modeled bow so I can test it for safety and have designs. Here are both of the limbs, the riser, and the full piece, and all of the components. This was very exciting for me given how much time I had to take on CAD, and now I get to actually have a bow that I can show people in CAD. Very exciting. So, quarter three. Quarter three was still a little more research on the layering, the hinging methods, and the stress points. So, with layering, pretty much every bow that's not metal is made out of layers of wood. The layers have been the bane of my existence. So, to get more power and more variation, limbs have typically 3 to 5 layers. The one I have has 4 layers, and so I had to model all of those layers very specifically to get the right dynamics. It has carbon fiber outer layers and bamboo inner layers. All of these give the bow different properties. Additionally, with the riser, I have a layered wood riser. So that has caused so many weak points for me, and I'll talk about that later. So stress points. On a bow, there are 4 major stress points. It is the limb tips and where the limbs connect. They are the places that are most likely to break when you're using a bow. And then I decided to add one more stress point in the middle. So I had to really focus on the safety and what was happening with these stress points to make sure it wasn't going to break on me. In quarter four was pretty much all of my welding. So I learned the basics of welding for this process. I'm probably one of the only people that can say I learned how to weld for archery. Here's me welding, and I had to learn a lot of different techniques. My first day welding was just entirely my uncle giving me pieces of metal and saying, make these go together. So it was a lot of fun. I've always wanted to learn how to weld, and so I plan on continuing this. And here's some struggles with it. So when you're wearing a welding helmet, it tries to make the light not blind you. But that means that you can't see pretty much anything. So over here in the corner is the difference of an exact same view through the welding helmet and not through the welding helmet. And that's when you're not welding. Here's a video of my uncle welding. You can see that the lights will just black out on you, and that's exactly when you need to see. And then here's just a comparison of what it looks like normally, and then what it looks like through the welding helmet. And that's not all up close and personal. So with my material, this is another issue, I had to use thin gauge material. It allowed me to have proper tolerances and be more specific, but it also caused me struggles with overheating, blowouts, and just general pain in burning the bow. So I had to use spot welding techniques where I welded one part, and then I go to another part, and then I go back. And that's really hard to do if you can't see anything. So that took me far more time than expected, which put me back in my timeline. I was able to eventually get the welding done, but it was a process. And then my original metal I had a zinc coating on it. I thought it would just make it look nicer. But actually, zinc coating, when welded and heated, turns into these little white fluffy things that'll go in the air. And if you breathe them in, it'll give you flu-like symptoms for weeks. So I had to find new metal that was the right gauge, cheap, and would work. So my uncle helped me with that. It was very fun. But now I just have a random sheet of zinc metal that I don't need. Then another welding struggle. I would use blocks so I didn't burn out my bow, but then the blocks would get stuck in there and I had to make this like weird welding soup to try and get OSB out. This took me over 3 hours to fix and really set me back given my limited time that I was able to be out there welding. Another struggle that was kind of common through this whole process was I get distracted easily. This is Tim. He's a cat that's out in the shop, and he doesn't let you pet him, but I was gonna pet him. So as soon as he walked by, I'd stop what I was doing, I'd chase after him. I never pet Tim. I was really upset, but it caused me a lot of setbacks. Not only this, but other things. I get distracted easily, and so I really had to focus on keeping myself on track for this whole process. And I just wanted to put a picture of this adorable cat on there. So finally, I got my hinging done. My hinge is a mix of 1/4-inch steel rods and the welded caps I put on the bow and the limb. I just put a hole through it, welded it on, and now I have working hinges. You guys can see the bow, the limbs entirely move. Woo! Drop the part. Stringing is the hardest part probably, but I was very, very excited. I was able to plug it a few times, no issues. Then I heard a cracking noise. It cracked and blew up. Hit me in the face, sent a screw flying, and I was set back another week with only a day to fix it. So I put a lot of JB weld in there, which is just kind of a two-part epoxy, and I just hoped it would work. I reinforced the crossbar, and it was working fabulous until I got here and I was demoing it yesterday and it cracked again. So last night, with the help of my dad, who's been wonderful through this whole process, I used more JB weld and that zinc sheet of metal that I couldn't use earlier, and I double reinforced it. So it kind of looks ugly right now, but last minute fixes don't have to be pretty. So here is the bow working. Here's me stringing it again, working. Ignore the weird outfit or weird things when I build. So here's a strung bow. Very exciting, no cracking noises this time. Here's me shooting it. And here's me de-stringing it. No cracking, no issues, until the next day. And here's pictures of the finished bow. This is what it looks like fully folded up. This is what it looks like fully together and strung. And then here's just a closer picture of the major components. And then do you guys a quick demo. So here's what the bow looks like built. And then I've been having to use pliers just because of how much JB weld I have in there. Breaks down in half, folds, folds, only about this big. So some major takeaways. I am really happy with my newfound knowledge. I got to get an intro to welding, which I've always wanted to do. I learned more about the manufacturing process. I got to learn the physics behind my sport, which was really exciting to me because now I understand why things happen, and I don't just have to point and shoot and hope. And then I got to sharpen my skills on CAD because with my career, I'll be using CAD for the rest of my life, so it's very important that I have good skills in it. And then some future hopes. One of my reach goals towards the beginning of this was to make it self-stringing, just like the real one. I talked to my advisor, he said there's no way I could figure that out in a year. He couldn't figure it out, I couldn't think of how I could even approach that, and so I hope to one day be able to do that, but it will need a lot more time than the 8 months we were given. Additionally, I want to make it happen in spring action expansion. I want to just be able to turn a lock, have it pop open. This was part of my plan. I have all the parts for it. I just ran out of time, so that is a future goal that I plan to do this summer. And then finally, I want to make this marketable. Bows are just a fun thing for me. I want to do it for the rest of my life, so I want to be able to make this marketable to an archery company for a hunting bow. I would have to figure out how to make it have a higher poundage and make it more accessible and manufacturable. Additionally, I'd have to have a higher poundage to be able to make it shootable. Hunting bows are typically 60 to 70 pounds. My competition bow is 40 pounds of force. This one clocks in around 18. So I'd have to dramatically change it to be able to do this. But I hope one day I will be able to. And then let's go back to my project objectives. Hopefully you guys agree with me, but I think I did an okay job at public speaking. So I'm giving myself a check for that. And then my time management skills. Not the best. I kind of left a lot of this to last minute for multiple reasons. I have other classes. There's a lot happening. I'm missing a math test as we speak. So there's a lot going on. Additionally, I can only go into the welding shop at certain points when my uncle's available and I'm available. So I got dramatically less time than I thought to be able to actually weld. So a lot of it had to be pushed to the last minute. But I hope to improve this throughout my life so I can be more efficient. Then obtaining a deeper knowledge of the engineering design process. I modeled it. I've gone through several iterations. I think I did a pretty okay job at this one. Then bettering my skills and perseverance. I didn't cry once through this. I'm really proud of myself for that. I wanted to cry a lot, but I didn't. And I mean, I have a finished project, so I guess I persevered through that. Finally, I want to improve my knowledge of manufacturing. I learned some basics of welding, and I learned how to make manufacturing instructions. So that was a huge part for me. While talking to my advisor, he told me that one of the major struggles college students have with their capstone projects is that they don't know how to make manufacturing instructions. So they build their thing up, they send it to the manufacturer tells them, absolutely not. And so I really wanted to think about the process of manufacturing through the eyes of an engineer and the manufacturer. And here's my bibliography. Thank you so much. Any questions? Riley.
If you had one more month, what would you do?
I would most certainly fix the middle brake that's currently threatening to blow up on me. And then I'd like to add the spring action. I'm so close, I have it designed out, I have all the parts. I just needed like 3-4 more days of welding to be able to do it. So that's definitely what I would do. Lena?
If you had an opportunity to do this kind of thing with a different type of bow, would you?
Yes. I'm very interested in how it would work with a compound, especially with the camming systems. There's a lot of things that go on in the compound, but I think that would be able to give me the force I needed to make it a hunting bow. Okay.
Were there safety precautions that stopped you from getting hurt in testing, or did you just really well?
A bit of both. I wear safety goggles, whole hoodie, gloves. My original plan, once I did all the spring action and the self-stringing, was to use a bow press at my bow shop that will draw it itself. But I didn't have time for that, so I just really hoped it wouldn't hurt me. Rena?
After fixing up the bow, would you ever consider actually using it for competition or for any practical purpose?
I would use it more for fun. This is around 18 pounds. That could probably get me like 10 to 20 meters. My actual competition bow is 40 pounds, and I regularly shoot 70 meters, which is 77 yards. So there's no way this bow will ever be able to reach there. But if I competed in bear bow for it, it would have so many issues with regulation. So I'm just using it more for fun and something to say, hey, I did that. We're both behind each other.
What are the main factors for increasing the draw?
So increased draw comes from the limbs. You make the limbs thicker and have different properties with different materials. And also you have to make the riser stronger. One thing that I wanted to do with my riser was make it out of metal, like my competition bow I use. Unfortunately, metal risers are way too expensive to be messing with, and so I had to resort to wood. But if I made it metal and stronger limbs, I'd be able to up the poundage.
You mentioned that you might be interested in getting a company to manufacture this. From what you know so far, why do you think that isn't currently a product like this on the market? What would you plan to do to overcome those challenges?
So there is a product sort of like this that my dad showed me because he had one when he was a kid. But it's pretty much just a piece of steel with 2 limbs on it, and it doesn't work super well. It's more of just kind of a kid's toy. And so I just think it's a lot of moving parts, and people have decided not to reinvent the wheel with all the bow technology they have. Anything else? Awesome, well thank you guys so much.
All right.